Hello guys, to my single linked list part 5. Okay guys, if you recall where we stopped in our previous video, we're able to create multiple node and write function prototype and function declaration in one single file, and we're able to iterate through those node and print the data we store in those nodes. So today what I want to do is that to show you guys how to build a software splitting your files into different folders and linking them together to create an executable binary that can run. Okay, and we're going to as well write a makefile that will allow us to build our program very easy, clean up the program and very easy. Okay, so without further wasting of time, let's dive straight into practice. Okay, I will just change straight into that directory. We have all files. You can see these are all files we have. Okay, if you could remember, these are where we stopped. So today I'm going to create different directories here, different directories. So I'm going to create a directory called bin, and also source, and also abj, which stands for object. I'll also create lib, where we're going to have our dynamic library created. Alright, I'm going to create a directory also called main, where we're going to move our other executable source files and binaries into. Okay, let me don't call it order, let me just call it old files. Okay, let's just store them there. Okay, we're not going to play with those ones. We're just going to store files, all the old, like the single linked list 2, 3 and 4, because this particular video is based on single linked list 5. You can see it on the screen. So I also create another folder called include. Alright, so press enter. If I do ls, you can see those here. So what I'm going to do is I'm going to copy every file here. Alright, I'm going to copy every file here into the old file. So I will do mv instead of copy. I will do move. So I'm doing, I will say single, anything that begin with single, that I'll put asterisk. What this means that anything that begin with single should be moved, okay, to the old file directory. So if I press my enter, I do ls, all those files are gone. But if I do ls in the old file, then you can see we have all of them here. So another thing I'm going to do is I'm going to use the cp command to say go into the old file. There is a file called single linked list 4.c, right? So we want to duplicate that file and save it inside here called single linked list. Okay, we call it single link list 5.c. Alright, so we press enter and that's going to create that. So if I do ls, you can see the single link list 5.c. so within this single link list 5.c is where we are going to do the modification of our code and splitting of our source files. Now if I do the vim single link list 5.c, you're going to see is the same code with the single link list 4. So what we're going to do is that all these function definition and prototype above here, you can see the prototype, you can see the definitions here below. We're going to move them into different files. So I'm going to start with the print. So I'm going to copy the line, so you can see where my cursor is. So I'm going to count downward. Where my cursor is right now is 1, the second one is 2, 3, 4, 5, 6, 7, 8, 9, 10. Then let me press I for insertion key so that I can copy more than 10. So let me say 11. I'm copying 11 lines. Alright, okay, let me count it again. 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm copying 11 lines. So how do I copy it? I press the escape key and I press 11 2 times and I press Y 2 times. You see 11 line yank. You can see it below here. Let me highlight it. 11 line yank. So I'm gonna save this file now. So ls, I'm gonna change into the source directory. So I'm gonna create a file with .c called print_node_data, and this is the same name with that function definition inside the single linked list 5.c. So I'm going to add it .c because it's an extension. Press enter. So I'm going to use the vim to open this, and what I'm going to do is next is to press the P to paste that. So escape, then press P once, and that pastes that. So I'll do I for insertion key, then start including other files, appropriate other files that we need. So first I'm gonna include the stdio.h. Alright, another header file I'm gonna include here is the one that we're gonna create for ourselves. So I'm gonna say, when you create your own header file, you're not gonna use the less than symbol, you're gonna use the double quotes. So I will say one step forward slash, that means move one step. The dot means move to the parent directory of this current directory. So there is a directory there called include. Move inside include. We have a file there called pen.h that we have not yet created, but we are going to do that. Then double quote, and that is it. So do we need any other header files to add? I don't think so. So for now we save this file. So I'll do escape shift colon wq, and that is it. So move one step backward again, and we use Vim to open it. So we do Vim single again 5.c, we go down and we take off the one that we have copied. So we take off this line. So I for insertion key, I'll just take off this line because we have copied this line, so we don't need it anymore. So we are now going to copy this one, this definition of the add node at end. So I'm going to count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26. So 26 line is what I'm going to yank. So I will move to the top. To be able to yank, you must move to the top, stay at the position where you want to start the yank, then press escape, then press 26 and press YY, and you can see at the bottom here is now saying 26 line yanked. Okay, so now that we have yanked it, we press escape shift colon, we come out of this file, and ls we change to the source directory. Okay, ls again, we will have the print node underscore data.c. So we're going to create another file that will be called add underscore node underscore, is it end, end, add node at end. I forgot it. Let me just move back and cut that file. So I'm going to cut the single linked list 5 to see the name again. Okay, it's called add node at end. Yeah, so I will change back to that source, then use touch to create is called add underscore node underscore at underscore end dot c. Press enter, use Vim to open it. Alright, so once we're in, we press escape and press P to paste. Now we paste that, you can see that. So we have all it pasted. So we're going to add the appropriate header files. I for insertion, then I'll move up. So here I know I need to include the print, which is under the stdio.h header file. I also need to include the for error number, which is less than errno.h. Okay, I remember we use malloc here, so we're going to include the stdlib, okay, .h, so that it can give us access to malloc and exit function. Then I'm also going to include our own library. So one step backward to the include directory / we have pen.h, which is not yet created, and we're going to create, and that is it. So is there any other header files we need to include? Yeah, there's one more, which is known as string. So I'm going to include the string.h, and that is it. So let me look if there's any. Yeah, I think there's none anymore. So there's something I'm going to do here. I'm going to take off this print here. Okay, it's no longer needed, so I'll do Ctrl U, and that takes that off. Alright, because we want to print it on a different line. So that is it for now, and we save this program. So one step backward, then we'll use Vim to open the single linked list 5.c, and we go down and delete that definition. So I for insertion, Ctrl U, just keep pressing Ctrl U, it deletes very fast. Alright, but you gotta be careful so I don't delete line that you don't want to delete. And I think that's all. Yeah, so that is it. So the next thing I'm going to do here is that I'm going to write something here. Alright guys, I'm gonna write something here. So I'll use a for loop again to say I'll say int I equals to count. So once I is greater than 0, then we want to decrement I. Okay, similar thing we do up. So now decrement here, I'm calling the print underscore node underscore data, where we pass in what the head, okay, that we're going to iterate to print. Once we are done, we close this. Then at the up here, I would like to add a new printf here, and I will say double quote, and I'll put backslash 2 times. All right, and I will now say printing node saved data. All right, and I'll put another double, and that is it. So isn't this cool? So the program is getting smaller. Another thing I'm going to do now is that I'm going to include here again, okay, if that is necessary. Yeah, if it is necessary. So I think that should be. So we're going to do hash include double quote dot dot. So not dot dot this time around, we're already in this current directory, so we'll do dot forward slash include forward slash pen dot h double quote. I'll press enter. So next thing is that I'm going to copy these structures and this function prototype. So I'm going to count it. So from here, 1 2 3 4 5 6 7 8 9. So I'm going to yank from 8. So let me answer. I'm yanking 8 lines. All right, so I'll press escape, and I'll press 8, and I'll press YY. 8 line is yanked. So I save this. So what I'm going to do next now is to go into the include file. So I will change into include, and I will create a file here called pen.h. all right, then we use vim to open the pen.h. then we'll start writing. Okay, that was a wrong typing. That should be vim pen.h. Now we can start writing the header file. So what we're going to do here, we're going to use the microcode I for insertion first, hash if not, if is if not, if not def, that means if not defined. What if not defined is pen underscore h. Then what we want to do is the same micro definition. We say if defined, if not defined, then defined underscore pen h. Now press enter. Then here we're now going to paste what we yanked. Escape, and I'll press P once and we paste that. I for insertion key. Then we have to come at the bottom here, okay, and end the if. So we say end if. All right, so this is a prototype. We're going to route this application to the .c file. All right, so this is the prototype that's going to route to the .c file in the /src directory. So we save this. All right, and that is it. So move one step backward. We open the vim space uppercase single linked list.c, and we'll go down here. Then we're going to wipe this line off again. So and Control U, and that takes that off. So now our program is very small, right? It's just 35 lines of code, but it's modern because of we have split the whole files. Isn't this awesome, guys? I'm teaching you guys how reward application I'm doing with it. So next thing is now to save this. All right, then next thing is to start creating our object code. So object code are file with .o extension. They are going to be saved in this directory called obj. Obj is abbreviation for object. So I'm going to create a file called makefile using the touch command. So it's going to be called uppercase M. Make will always start with uppercase M. So there's a program called make. It searches within the directory for a file called makefile, and it goes into that makefile and listens to every rules applies and use that rules to compile our program. So it makes things very easy for us. So we create that file ls. Then you can see we have the makefile. Then now we can start writing the makefile. So we open the makefile. Okay, instead of me compiling everything one after another, so we just use makefile. So we go into the makefile. Here we can now start doing what we want to do. So first of all is that I for insertion key. I can create a variable here, but to make things simple, I'm just going to be very like, you know, cool, guys. I don't want this to be like, you know, verbose for you guys. So I'm gonna say all. This is the target. All right, column, press enter. So I'm compiling. First of all, I'm creating an object code. So the object code should be minus f peg space minus c, or should be minus c, should just come first before the minus f peg. All right, so what are we compiling? We are compiling what is in this current directory slash src slash add. Okay, let's say instead of we putting the add.c and this, we just say everything that end with .c. all right, so we are creating that. We can make it different objects, so let's do it that way. So I add different objects so that you guys see actually what this thing means, because me using all this, you know, tricky way to do stuff might make you guys not to understand. So I will just put it where you guys can understand very well. So underscore node underscore arts underscore end.c. so output this to slash, that means in this current directory move to obj /. Okay, let the name of the file be called add underscore node underscore arts underscore end.o. all right, so that is just it. So the next thing, to the other file, minus c space minus f peg. Okay, then dot / source slash, then this one is called print underscore node underscore data dot c, right, space minus o. Right guys, so now we got that set. So the next thing, where are we moving it, is in this current directory obj /, we want to call it the same name, print underscore node underscore data, okay, dot o. All right, isn't this awesome guys? So this is awesome. Now we are done with this. So another one we want to create here, we want to call this target library. Okay, we want to call it library. So put our column and we press enter. So this library, we use the same GCC to play this library. So we should put minus shared, which is the flag for creating library. So what will be this name of this library? So we want to say let's call this pen node, okay, .so. So what are the files, okay, we are using? Okay, so we are saying we are going into the current directory obj / everything that end with .o extension. Okay, so shouldn't be dot here, should be / everything that end with .o extension. Okay, so we want to say -o, so here should be -output, right? Everything here that end that should be given to this file here, should turn to pen. So I'll just put L at the front to call it link. I think that makes sense, isn't it? I think that makes sense guys. All right, I think it makes sense more. Or maybe I should call it lib pen or lib node. There's no need of adding pen. Let me just say lib node.so. So the SO here stands for the object share library that we are creating. All right, so that is just it. Then after that, we are moving we are getting the file to here. So this share library, where do we want it to be saved? So we say dot /, we want it to be saved in the lib directory /. So that should be where it should be saved. All right, that's very, very simple. Okay, so now I think this is nice. Then the next thing is compile this program. I've not added the clean up though, but for now I just want to make things simple, so I clear the screen ls. All right, so this will create both the object code and the .so, which is the share library itself. So for me to do that, if I type make all it will create this one first. So if I do ls obj, we see the .o files. Now you can see that. So the next one is we type make lib library. That was what we called it. Then it's going to create that share object. So if I do ls lib, you can see the share object there, libnode.so. So this has been created now. So all those has been created. So we have stuff in this directory, we have stuff in this directory, we have stuff here in this directory, we have stuff here in this directory. So what does not have stuff is this, where the actual executable code will live. All right. So how am I going to do that? So what I'm going to do, I'm going to say this program, which is the main program, okay, I'm going to write another rule that we call run, that we that we compile the program, put it in the bin, and then what, and run it. So we're going to go back to the main. All right, okay, sorry, the make file. Then we're going to add a last rule. So the last rule we're adding here, the right target we're adding here, I for insertion key. Okay, I'm going to say run column, I press enter. So I will do the same gcc. So now that I want to compile read time, okay, now I want to compile read time. So this is what I'm going to do. Say, since our program is called single, right, it's called single link, if I'm correct, list 5.c. So that is our actual source code. So we are doing something like, we can put something like the path to where our library is, or we can do something like minus uppercase L, which stands for link. What are we linking? We are linking stuff from this current directory, but since is not in this current directory, so I can put the absolute path, which I know is ./lib, okay, / is called libnode.so. okay, so I know that is where it's sourced. So I want to say output this code, that means the executable binary to ./bin, and I want this program to be called single. Okay, let me just call this program, let me call it main, just main program. Doesn't it mix up? Let's keep on with the vibes. Single link, that was not the spelling of link, list, and that is it. So it's going to give the program that yeah, so let me call this, instead of run, let me call this, yeah, run. That is when it compiles, it compiles and also runs. So to run the program, I will now say ./bin / then I will now do single link list. Okay, so that will help us execute the program. Then we should also have a directory here called clean. Yeah, so we use the rm, okay, space minus rm. We are saying go to this ./ bin / and delete the link _ list. All right, isn't that cool? Okay, so that anytime anybody is using this program, he has to originate this executable binary when he cleans it up. All right, I think that is nice. Okay, so instead of me calling this all, I think let me call this let me call it I think let me just call this compile. Okay, then this compile here, I'm going to have a target called all. Okay, all will contain compile. It will also contain library. Instead of me typing all of them every time, it's going to contain one and no clean. All right, so clean will be called exceptional. So I think this will look nice. All right, so yeah, so let me just go now run this program. So if I do make, all, so it will just do everything for me. So you see the program starts. Are you seeing it? Isn't that awesome? So you see enter number of node you want to create. So let's say you want to create 3 node. So you say enter number of your node. So I will say 10. You're gonna say enter another one. I'm gonna say 20. Enter another one. I'm gonna say 30. I'm gonna say print node save data. Printing node saved data. I say data save was 30, 30 and 30. Okay, yeah, that was where the program is getting fault. It's not printing 10, it's not printing 20, it's not printing 30. All right. The reason why that happens was because the print function was actually called at its own pace. So that's why it was not pointing to that. So for us to be able to do that, we just have to clear the screen, do ls. Now open back the single linked list dots. No, not the single linked list. We have to go to the source. So we change to the source, and we use vim to open the print. Then in the print here, instead of say pointing to temp link, all right, so we are saying, let's say here we say temp should point to link. All right, temp should point to link which is equals to so once temp points to link, let's say since temp is now equals to head, so it's pointing to link, and the link we also point to the next okay, this will make us to rewrite the program entirely. So let us keep it the way it was. So maybe my next video, this will make me to rewrite the add node at end and make the program, this video, more verbose. So just make things simple. So 10 points to this and link. So that is it. So I will just save this code and yeah, just save this code, and I will move one step backward. No, instead of that I will open the add. Okay, I will open the add and I will come here. So what I'm going to do here is I'm going to come here, say I, so I'm going to call the print here, I'm going to call the print underscore node underscore data. I'm going to pass in the head, and that is it. So and that is it. So we save this and I move one step backward and I run make all, and that is it. So the program now run proper. So we say 3 and we say 10 and it will print that data saved 10. Then I will say 20, it will print that data saved 20, and if I say 30 and it will print that, and it breaks out. Still yet the low print. The reason why this printed was because of that was the last node, and we did that in the single linked list here. You can see the iteration we did here. Okay, you can see the iteration we did here. So we should just ignore this now. So Control U, and that is it. So what I should just print here is print F. So this should be exiting program, right? Exiting, is it exiting? No, exit, yeah, exiting out of program. All right, I think that's nice. So /n/n. Then here we should have another new line here, one double quotes, and yeah, you see, as I am making changes in the program, I don't need to do anything. All I once I make the change, I just come here, I type make all, and it builds the program starts. That is the beauty of make. Then if I say 3 and the program is gonna run well. So if I say 10 that prints 20, that print, then 30, that print, and say exiting out of program. Okay guys, if you love this video, please make sure you give me a like, okay? And if you're watching this video from my YouTube, make sure you click the subscription button and give me a like as well. If you're watching from TikTok, share this video to your friends and invite most folks. Okay, lastly, before I go, guys, my academy is open for any of you that want to enroll for my academy, okay? And it's very, very cheap, and which is going to be very up soon, okay? The duration of payment will be about 2 months, because we're talking about 200 to 300 people coming in to learn programming, just as C programming, just as Python, learning hacking, cyber security, learning Linux, just as bash scripting and Linux advanced to professional command line. Okay, we also have course on Git. Okay, for this one, going to DevOps Git, essentially going into the depth core of Git. Okay, so if you want to learn, please hit me up, share the video, and give me a feedback. Thank you. Okay, all right, bye.